In my last video, I discussed what a logarithm is. We talked about how log is the exponent that the base needs to be raised to get to the argument. We can put many different numbers for the argument and solve for log. Sometimes we see it as a function with x, since this x can change. So let's add this y equals to make it look like a function. Logarithms and exponentials have an important relationship. They are inverses of each other. Since we've been discussing exponential functions, let's put this into a question in terms of exponential functions. So we have our base is the same for the log function and the exponential function. So what is our exponent? Remember, log is the number of times 10 has to be multiplied to get the argument. So the answer to the log is the exponent of 10. And what is that going to equal? Well, log of x means how many times do we need to multiply 10 to get x. So that means that the x is the answer to the exponent evaluation. So here, let's move the x over to the equal sign. While we have these two equations written like this, let's take a look at some properties. So we have this y here, and here we have an expression y is equal to. So if we just rewrite our y and the exponent as that, we get this expression. So this is one of the properties of inverse functions. 10 raised to the log of base 10 will equal the argument. And we can do the same for x. We see we have what x is equal to in this equation. So x is 10 to the y power. And we have the x over here in the log equation. So we can substitute in for that x. And like the other way, we have that the log base 10 of 10 to any power is that power. Let's do a little practice. If I know that log base 10 of x is 3, then what is x? Think about it for a second. How would you know what x is? What does the log mean? Remember, it means how many times we have to multiply the base, which is the exponent of the base by definition. So we know that we are going to multiply 10 3 times. Or we can also say raise 10 to the third power. So we have 3 is our exponent, and that is going to be equal to x. But we can actually evaluate 10 to the 3, right? 10 to the 3 is 1,000. So we know x is 1,000. Let's do another. What is log base 10 of 100? Using the relationship of log with exponents, this is the same as 10 to some power equals 100. So to find the log we are asking, how many times do we multiply 10 to get 100? But we know 10 times 10 is 100, right? So we multiply 10 2 times. So 10 squared is 100, and that means log base 10 of 100 is 2. Let's see what the log is if we have a 10 here. We are looking for the answer to the logarithm, so the unknown is this exponent here. And we are wanting to know when that equals 10. How many tens do you need to get to 10? The answer is 1. So the answer to log base 10 of 10 is 1. What if our base is 2 and we want to find log base 2 of 2? So now our base is 2 and we have a 2 here from the log argument. So we need to figure out how many times to multiply 2 to get 2, which you probably will answer that's 1. So the log base 2 of 2 is 1. So you can probably see it doesn't really matter what base you have. The log of its base is 1. What about log base 2 of 1? Bear with me, I know you're probably tired of doing these, but this one's special. Okay, so what does this mean? We have 2 multiplied how many times to get to 1? Okay, think about this for a second. Can you ever multiply 2 with itself a certain number of times to get to 1? If you are unsure, check out the video on properties of exponents I made. I talk about the zero exponent rule and why this happens. We know that this exponent must be 0 if we are getting 1 as the answer. And this is going to be true for any base. Before we finish, I'm going to leave you with a thought. What do you think would happen if you put in a 0? Can you ever multiply a number over and over to get 0? What about a negative number? When can you multiply a number over and over to get a negative? Think about it a bit. What restrictions would you have to put on the base? Or here, A. That's enough for you to chew on. Think about these questions and stay tuned for my video on the domain and range of log functions.